Right, good day to our international audience watching from all around the world. Billions of people tuning in live. Just to let you know that in Joburg it's a rainy day, which is terrific. We'll have water for the winter, and on top of our corona problems, that is at least some good news. Right, so we're carrying on with compound angles. Guys, on your information sheet, you've got these formulas. Please keep referring to them. Okay, remember, but you should have the patterns in your head. Okay, and the way I always remember it, as this is another video, for cos, what's the messed up thing? The messed up thing is that the sign is different to the original sign. Okay, so that's plus and that's a negative. But the good thing about cos is that the cos are all together. With sine, what's the messed up thing? The messed up thing with the sine. With sine, compound formula is that the sine and cos are all messed up. The good thing is that the sine is the same as that. There, the sine is the same as that. Okay, so you need to have those patterns in your head. Sometimes you work from left to right. Sometimes you work from right to left. All the sums we're doing today involve no calculators. Okay, and you can either go use your right angle triangle. Some people prefer that. I use this diagram. A circle with a radius of 2 will have coordinates at 0 of 2, 0, at point of intersection with the circle 30, root 3, 1, 45, root 2, root 2, 60 degrees, 1, and root 3. Okay, so those are the two things we're going to be constantly referring to. Remember, no calculators for the whole exercise. So, sharers, tell me please, evaluate cos 15 without a calculator. Okay, that little group, you guys, Maxine and Tombe, get going. Right, so cos 15 without a calculator. Well, we've got to get it to a special angle. And we're going to have to use compound angle formula to get it to a special angle. So how could I write cos 15 in terms of two special angles? Okay, well 90 is not going to work. Okay, so we could do 45 and 30 because cos 15 is the same as cos 45 minus 30 degrees. All I've done is I've rewritten the 15 as 45 minus 30. Okay, right, so now go apply a compound angle formula. You're going to use this one over here. Okay, go apply that, then go apply the special angles. Try to do it without a calculator. So it's going to be, well, with cos, the good thing about coses are together. The bad thing is that the sign changes. So I end up with that. And those are all special angles. So cos of 45, cut each of those. All of those four ratios using that diagram over there. Give that a go. So cos is the ratio of the x coordinates over the radius. At 45 degrees it's going to be root 2 over 2. Cos of 30, at 30 degrees the x coordinate is root 3 and the radius is 2. Sine 45 is the y coordinate over the radius at 45, which is going to be root 2 over 2. And sine of 30 is going to be a half. I do times fractions, multiply the top times the bottom. So I get root 6 over 4 plus root 2 over 4, which is equal to root 6 plus root 2 all over 4. Happy days, happy days, happy days. Lovely. Greetings. Well, I may be loving this weather, but my horse is looking pretty miserable out there, and there's nothing worse than a wet horse. Right, so the next examples we're going to be doing, again, we're not using calculators, and the examples we're going to do come from Mindborn Math, exercise 4.3, page 136, so please get out your textbooks. And we're going to do question B, D, G, and H together. As always, try them first on your own, and then have a look at the solution. So B number 1 says, show that sine theta plus 30 minus sine theta minus 30 is equal to cos theta. So let's just start with the left-hand side. So for 1, we've got sine theta plus 30 minus sine theta minus 30. Okay? So we're just going to apply our compound angle formula, and sine of one angle plus another angle is sine of the angle sine 30. Here was speaking rubbish. Sine theta cos 30 plus, and they swap around, but the sine stays the same, plus cos theta sine 30. So that's that over there. Okay. Then I've got a minus sign, and I'll be careful, you're minusing the whole thing, so don't forget your bracket. So it's going to be bracket, okay, sine theta cos 30, okay, with sine, the sign is the same, so it's still going to be a minus, okay, and then they swap around, cos theta sine 30, right. Now don't forget, you've got to distribute the negative throughout that whole bracket. So what's going to happen then is you're going to have sine theta cos 30 minus sine theta cos 30. So these, that and that are going to cancel each other out, well, that gives you naught. And then we're going to have cos theta sine 30, okay, and this becomes minus and a minus makes a plus. So it'll be cos theta sine 30 plus another cos theta sine 30. Okay, a chicken plus a chicken is 2 chickens, so this is cos theta sine 30 plus another cos theta sine 30 is 2 lots of cos theta sine 30. Right? But sine 30 is equal to a half, so you end up with 2 over 1, that's that 2. Sine of 30 is a half, and we've still got that cos theta. So 2 times a half is 1, so we're left with an answer of cos theta. Okay. Right, which is what we wanted, because the question said show that that's equal to cos theta. Now, hence, guys, means they're trying to give you a hint. They say you must use, they don't have to, sometimes they use a hint or otherwise. In this case, I did say hint, so I guess you have to. Now it says go use this answer to evaluate sine 75 minus sine 15. Okay, so give that a go. Right, so now we've got to evaluate sine 75 minus sine 15 without a calculator. And it says go use what we proved. So even if you didn't prove this in an exam, use it to do part 2. Because I said show that, so it is true. Okay. So I've got to write it in the form 75, I've got to write as something plus 30. Well, what plus 30 is 75? 45. So I'm going to get sine 45 plus 30 degrees, that's sine 75, minus, then we've got to write it as the same angle. It's going to be the same angle. Theta refers to the same angle. So our angle is 45. So we're using theta. This is our theta. Okay? In that case over there. So it's sine 45, which is our theta again. So I've got that pattern. If it's hence, it means get it into that pattern. So it's sine of an angle plus 30 minus sine of the same angle, which is 45. That's what that's saying over there. Minus 30. So there's our theta, right? And we proved that in that, when you've got that pattern, sine of an angle plus 30 minus sine of the same angle minus 30, it'll be equal to cos of that angle. So in this case, theta is 45, so this must be equal to cos of 45. If you want, you can say, give this a thing and call it whatever, star. You can say from star. Right? And then cos of 45 is, go to 45 degrees. What's the x-coordinate? It's root 2. And the radius is 2. Voila, and I've done what I set out to prove, that that's equal to root 2 over 2. Lovely stuff. Okie dokie, ratbags. Right, so the next question says, show that root 3 sine theta plus 60 minus sine theta plus 30 is equal to cos theta. Right, so let's work with the left-hand side. So the left-hand side is going to be root 3, okay, times by the whole expansion of this. And sine theta plus 60 expands to sine theta cos 60 with sine, it's the same sign, so it's a plus, and they swap around, cos theta sine 60. So that's that expansion over there. then I've got a minus, and I'm minusing the whole thing. So let's put a big bracket, and that's going to be sine theta cos 30, sine theta cos 30, then the same sign, which is going to be a plus, so it's going to be plus, then they swap around, cos theta sine 30. Right. Now, we still don't really have like terms there to add, so let's now evaluate our special angles. Okay, because there are no like terms like the previous one. Okay, you cos theta sine 60 and cos theta sine 30. Okay, so here I'm going to have root 3 sine theta. Well, cos of 60 degrees, at 60 degrees the x coordinate is 1 and the radius is 2. Okay, plus cos theta at 60 degrees, sine is the y coordinate, which is root 3 over 2. Then it's going to be minus sine theta cos of 30 degrees is going to be x coordinate, which is root 3 over 2. Now be careful. Don't forget this negative. And you did there. Negative times a positive is a negative. So it'll be negative cos theta, and sine of 30 is y coordinate over radius, which is 1 over 2, which is a half. Don't forget this root 3, I didn't close my big bracket, has to be distributed throughout there, right? So I end up with root 3 over 1 times a half is root 3 over 2 sine theta, if I times root 3 by a half. Okay, then root 3 times root 3 is 3. If I times the numerators together, I get 3. The denominator would be 2, 3 over 2 cos theta. And then I've got minus, just changing the order around, root 3 over 2 sine theta, okay, minus a half cos theta. Check that makes sense. Okay, now you're going to add like terms. Well, a chicken minus a chicken is no chickens, so that disappears. Okay, root 3 over 2 sine theta minus root 3 over 2 sine theta disappears. 3 over 2 minus a half, okay, 3 over 2x minus a half x would be 1x, so this is just going to be 1 cos theta, which is just cos theta, and voila, we have proved what we set out to do, that is equal to cos theta. Right, get that down, and then try D part 2, which is going to use this answer, okay, because it says hence. Hence, hence, hence. Right, so part 2 is quite nice actually. So you've got to use this. It says use, because it says hence, root 3 sine of, what is it saying? Root 3 sine of an angle plus 60 minus sine of the same angle, those have got to be the same magnitude, plus 30 will be equal to cos of that same angle. Okay, so we've got to figure out first of all what this angle is going to be. Well, I've got sine, and so it's about matching up the pattern. Well, sine and sine, that's a good sign. Okay, so this could be written as 20 plus 60 if theta was 20. But if theta is 20 here, okay, we'd get 50. And the other problem is this is sine and this is cos. So if I'm going to use this pattern, I have to change this cos into sine. And what can I use for that? Well, I can use complementary angles. Why? Because cos of 40 is the same thing as sine of 50. So we're going to do that first. Okay, I'm just going to work with the left-hand side. So the left-hand side is root 3. Let's just keep it as sine 80 for now. And all I'm going to do is change the cos 40 into sine 50. Now it's looking more promising because I've got sine and sine. Okay, and let's go back. I'm trying to link it up with this pattern over here, remember? So I've got sine, and I've got sine, and I've got a minus in between. So that's a good start. Now, can I express these as one angle plus 60? Well, what's 80 going to be? 80 will be root 3 sine. Well, theta would have to be 20. So it'll be 20 plus 60. Okay, so that's that bit over there. Then I've got a minus sign, and it's going to be minus sine. Well, 50 I could write as 20 degrees plus 30. So I've got in exactly the pattern I want. we have got an angle plus 60, and then the same angle, okay, plus 30, right? So this is my theta from part 1. And we know, we proved in part 1, that this thing would all be equal to cos of theta. So, in other words, that whole pattern, theta is 20, must be equal to cos of 20. Am I done? Not quite, because I'm trying to show that that was equal to sine 70. But complementary angles, remember cos of 10 is the same thing as sine 80, cos of 30, sine 60. So cos of 20 will be the same thing as sine 70. I really like that question, very nice. Get it down, try and make sure you understand it. Remember with a hence question, you're trying to match up the pattern of what you're given to where you want to go. Okie dokie humans, right. Then the next question, we're doing question G from exercise 4.3 of Mind Born Maths. You've got a triangle ABC. The first question says determine A in terms of B and C. So that's not rocket science. Okay, we know that A plus B plus C is 180. So A must be equal to 180 minus B minus C. Right? Then it says hence. Show that sine A is equal to that whole thing over there. So hence means go use this answer. So we can start off, even if we're not quite sure what we're doing, we can say, okay, they want me to use that. So sine of A is equal to sine of 180 minus B minus C. Now in the answer, I've just got B's and C's, no B plus C or anything like that. Okay, so I'm going to have to use, okay, I would pair them up like this. Your compound angle formula deals with sine of one angle plus or minus another angle. So if we do this and say, okay, let's consider our first angle as 180 minus B. So this is our first angle. Because if B was whatever, 20, that would be 160. Okay, and we'll consider C as our second angle. So I've got sine of an angle minus another angle. And the compound angle formula says sine of an angle minus another angle, I'm using that formula over there, will be equal to sine of the first angle, which is 180 minus B, okay, times cos of the second angle, which is C. So it's sine 180 minus B cos C. Then the sign in between is a negative, so it's going to be, for sine it's the same, so it's going to be a negative in between. Then they swap around. So it's going to be cos of 180 minus B, okay, times by sine C. Right, so now, well, sine 180 minus B, if you want to bracket those off, if I use reduction formula, please don't use compound angle formula there. If you get 180, 90, 270, unless they've explicitly told you to use compound angle formula, just use normal reduction formula. So sine 180 minus beta, I'm in quadrant 2. What happens to the sine there? It stays positive. So I get sine B cos C, and then minus, well, cos 180 minus B, I'm in quadrant 2, cos is going to become negative, so it's going to be negative cos B, and sine C stays the same. Okay, so I end up, let's pray I've got the right answer, with sine B cos C, a negative and a negative make a positive, plus cos B sine C. Voila, that's what we wanted. Okay, get that down, one more to go. Right, you'll all be pleased to know that Madam Violin has come down and she is preparing herself some coffee while I've been hard at work. I've been relaxing because it is a Saturday after all. And being such a man of the land, I have prepared some granadillas, homegrown granadillas to go with her, all bran flakes. Darling, with love, I present you some granadillas. So wait.
Thanks, honey bun.
Right, now
Sweet cake, sugar plum.
let's try this. So it says given sine theta plus 60 degrees is equal, this is question 8 from Mind Born Math. Okay, we're given sine theta plus 60 is equal to 2 sine theta. Show that tan theta is equal to root 3 over 3. So you've got to just calm the farm, okay, and start with what you're given. You're not going to just look at this and know how you're going to do it. So you've got sine theta plus 60, given that is equal to 2 sine theta. From this, it's somehow I'm going to show that it leads to that. Well, the only thing I can do is apply the compound angle formula. So that's going to become sine theta cos 60, and the sign stays the same, so it's a plus, then they swap around, so it's plus cos theta sine 60, and that we know is equal to 2 sine theta. Right, nothing much we can do with that apart from evaluate the special angles. So therefore we have, well, cos of 60 is x of r, which is going to be a half. So I get a half, which is cos 60 times sine theta. Sine of 60 is y over r, which is root 3 over 2. So plus root 3 over 2 cos theta, that's sine 60. And we know that that's equal to 2 sine theta. But now I've got to show that that's equal to tan theta is equal to root 3 over 3. So the only link between sine, cos, and tan is that tan is equal to sine over cos. So let's get all our sines on one side and all our terms with cos in on the other side. So if I get the sines to the right hand side, I've got root 3 over 2 cos theta is equal to 2 sine theta. I'm moving that across, minus a half sine theta. So I end up with root 3 over 2 cos theta. Well, 2 sine theta, 2 minus a half is 4 over 2 minus a half, which is 3 over 2. So it's going to be 3 over 2 sine theta. I can get rid of the 2 by timesing both sides of the equation by 2. So I get therefore root 3 cos theta is equal to 3 sine theta. Right, and now tan is sine over cos. So if I divide both sides by cos, I get root 3, you can skip out steps, okay, is equal to 3, well, sine, divide both sides by cos, sine theta over cos theta is tan. So I get root 3 is equal to 3 tan theta. So therefore, divide by 3, root 3 over 3 is equal to tan theta. No doubt the audience is amazed. People are applauding at home. They are excited by this riveting stuff. Get that down. Right, scum, all that's left to do is I want you to go to exercise 4.3 of your Mindful Maths, page 136, and do the ones that we haven't done. In other words, A, C, E, F, and I. And the memo is posted. And have a tremendous day. Say goodbye.
Bye.
Bye.
Bye.